Hi everyone, welcome back to this AMC series, and we're here today to continue to discuss counting. So last time we talked about letter arrangement, how to construct three-letter words, four-letter, whatever, and this time we'll start with casework, a strategy that you could use in counting. So from what we learned last time, when we're trying to do something, we can break it down, look at the simpler version of the question, and then go from there. And this time, we'll look at something a little bit different, which is casework, but you're gonna use what you've learned from last time. So let's take a look at a problem. M squared plus n is less than 22. I made the numbers up, so hopefully they work out fine. But so for this question, you might think, oh, and that m and n must be positive integers. So nz, and they are greater than 0. And if you aren't really familiar with what integers, prime, composite, whatever those are, you could look back to the number theory video from a few times ago. And this is what's really cool about math. It's all interconnected. So for the number theory video, you might think, oh, number theory is a completely different field from counting, so it's not going to be that related, except that we still have numbers, still have variables like that. But actually, we use the same knowledge over and over in different fields of math. So let's get started. You might think, oh, there are so many choices for m and n. I'm just going to die right here, right? Well, actually, no, you're not. Because you could break it down into cases. What do I mean by that? I mean that cases are just smaller version of the problem. And that, for example, if you have a gymnasium, you want to break it down into 4 squares. So, for example, someone's playing baseball over there, someone's playing volleyball, someone's playing dodgeball, someone's playing football, let's say. There are 4 different sports happening in the gym right now. And they're all separated. And you want to count how many different students are actually in the gym, right? Then you count how many students playing volleyball, how many students playing dodgeball, how many students playing baseball, how many students playing football. And then from there, you get a total number of students. So how this really works is that you want to count number of something, let's say, and that equals to number of a part of the something plus number of, let's say this is part 1, part 2 of the something, and then plus like that until you get number of a part n of something. And the cool thing about this is that you could break it down to how many parts you want. But remember, there is a slight restriction, is that you have to make sure that all of your cases cover everything that you're trying to count. So everything of the number of something. You have to count everything and not just some parts. Because when you add them up, they don't get you everything. And that may seem a little bit confusing, but let me show you. So for example, if you have 7, you want to break it into cases. This is not like the best example ever, but I'm just still going to use it. You have 3 cases. Let's say it's 1, 2, and 4. Maybe there's a problem correlated to this, but I'm not sure. I'm not confident in that. But let's say you have 7 is number of students, right? This is number of 9th grade, number of 10th grade, number of 11th grade. So, and that the school is only a 9, 10, 11 school, okay? So when you try to count the cases, you want to count the number of all students equals number of 9 plus number of 10 plus number of 11, right? Yeah, but that's the cases part. But then remember that you have to cover all of the number of students. So what you can't do is you do number of students equals number of 9th graders plus number of 10th graders. You know, right now it may seem really obvious. Oh, yeah, of course, you're leaving out the 11th graders. But when you do more complex counting problems, mistakes can happen. You might think, oh, I'm already counting everything. Well, actually, you might not be doing that. You might actually left out some problems, some groups. That's like counting America without counting the Asian population. You're not gonna get the entire number, right? So that is not what we want. We want to make sure that our cases cover everything. So that's the first thing. Second, you want to make sure that your cases aren't overlapping, right? That's one of the most important things. So what I mean by that is that if you think about the number of students example, you have 9th, 10th, 11th graders. Now you count how many student takes sports, different sports, baseball, basketball, and football, let's say, those 3 sports. Let's say this is an all-male school. There are, let's say, 6 people taking baseball. There are 3 people taking football. There are 5 more taking basketball. That is gonna give us 6 plus 3 plus 5. That is 14. How many students are there? 7. And that is why you can't count back the number of sports because they overlap. You see, there might be some student playing both basketball and football. And you counted that student twice. And the same thing can happen with baseball. You cannot do that because you're gonna get a lot of the same people, but you count them multiple times. That is not allowed. So that is the second thing about cases. And the cases are so amazing because they can solve us every problem we want. Thank you for watching and bye.